Hey, third grade, I am going to make you a quick video on measurement. Miss Allen is getting to measurement in class, and if you're not there yet, then just kind of save this video for when you do get there. I don't know when she's going to get there, but I wanted to get it made ahead of time just so you're ready. It is going to be a little bit harder for me to show you measurement on a virtual platform like this because I don't have a ruler right in front of me, but we're going to do our best. So we're going to be in your book on page 232. There's not much to this measuring. It's really pretty straightforward. You just have to know how to be able to read a ruler and to read certain measuring devices. So on page 232, it says, what is the length of this key to the nearest quarter inch and half inch? So you know what a ruler is. You've all used a ruler before. We use it to measure how long something is. So let's look at the ruler they give us. A ruler is 12 inches. So we have an inch. So what they give us here is a 0. You always start at your 0. It doesn't matter if the 0 is on the edge. Sometimes the 0 will be all the way over here. It doesn't matter. You always have to start at the 0. So let's go 1 inch right here. So the 1 inch mark, I'm just going to put inch underneath it, IN. Those are the longest ones. They go all the way up to 12 on a ruler. When you get to yardsticks, it goes further. But a standard ruler that you would use in school is 12 inches long. In your inch, you have a half an inch. And a half an inch is just what it sounds like. It's literally half of an inch. There are 2 half inches in every inch. So we have this part that's half, this part that's half. You already know that a half plus a half equals a whole. So 2 halves equals it. In between our halves, we have quarter inches. A quarter inch, quarter inch is 1/4 of an inch. That means that if we took 1 inch and we split it up into 1, 2, 3, 4 parts, we would have 4 of them. So 1/4 of an inch, there are 4 of those in 1 inch. So we have the 1 inch mark right here. We have a half an inch right here. And then our 4ths of an inch are going to be here. So we would have 2 in every half an inch. Then it says sometimes you can measure, sometimes the length of an object is not a whole inch. You can measure length to the nearest quarter or half inch. Line up the left end of the key with the 0 mark on the ruler. So you see there that they lined it up. Round length between 2 marks to the closer mark. So we see it goes past 2 inches, but not all the way to 3 inches. So I'm going to clear this and see if I can kind of draw that out. So they give us a ruler, and it starts with 0 inches, 1 inch, 2 inches, 3 inches. In between 0 and 1, you see 1, 2, 3 little dashes. 1, 2, 3. In between, we have 1.5. Then we're going to have 2 dashes in between each one. Then we're going to have 2.5, dash, dash, and then I'm going to stop there. So our key goes from here. I'm going to actually take that, I want to line it right up to the edge. And it goes all the way past 2.5 to this little mark right here. I'm not going to draw the actual key, but that's where it lines up. So it shows us that the right end of the key is closer to the second mark after the 2 inch than to the 3 inch. So that's 2.5. So 2.5 is right here. So we know it's bigger than 2.5. So let's go to the nearest quarter inch. Now remember, there's 4 quarter inches in 1 inch. So this would be 2.5. So this would be 2 3/4 right here. So this means we're 2 3/4 way. Now, if we have something like this that you did with fractions, that equals a whole, right? So we don't say that there's 2 4/4 quarters, because that would just mean 3 inches, which we're not there yet. So since it goes to the mark after the 2.5, we're at 2 3/4 of an inch. or 2 3/4 of an inch. So let's look. On the next page, it gives you some objects to measure. I'm not going to be able to show you that because you're going to have to actually have a ruler and do it. The same thing with drawing a line. You should be able to get a ruler and draw a line. It's super simple. Line it up, start at 0, go as far as it tells you to go. So let me show you this just one more time. If I have a ruler, 0, 1 inch, 2 inches. Let's kind of zoom in on it. This is going to be 1.5 inches. So in between 1 and 2 is 1.5 inches. This one is going to have 2 and 2. So this would be 1.25. Oh, I'm sorry. Look at what I'm doing here. If I had 1 2/4, that doesn't make any sense because that's the same as that. So I'm actually going to erase that real quick. Then 2, I shouldn't have put that there, sorry. 1.5. Then the next one would be 1 3/4. So this 1.5 takes the place of the 1 2/4. And then we don't go to 1 4/4 because that's 2. So in between, I'm going to try to clean this up a little bit. Let me clean it up and make it a little bit easier to understand. So we have 1.5 here. So 1 1/4 is in between 1.5. After 1.5, we get 1 3/4. Then we get to the next inch. After 2 inches, we would have 2 1/4, 2.5, 2 3/4. So let me show you that one. So if my zoomed in ruler starts at 2, ends at, no, let's make it end at 4. So halfway between 2 and 4 is 3. Halfway between 2 and 3 is 2.5. Halfway between 3 and 4 is 3.5. So let's fill in between. In between 2.5 is 2 1/4. In between 2.5 and 3 is 2 3/4. In between 3 and 3.5 is 3 1/4. And in between 3.5 and 4 is 3 3/4. So that, I think, was a nicer and neater way to show you that one. So then let's look at number 9. It says, Mara said the length of the marker is 4.5 inches. Explain why Mara is incorrect. So look at what Mara did. Mara started measuring at 1 inch, which we know is incorrect. So Mara got her answer completely wrong because she started measuring at 1 inch. I'm not going to give you the correct answer because I'm not sure if Ms. Allen is going to give you that for classwork, but remember, you always start at 0. Okay, so let's move on to the next lesson. The next lesson is measuring liquid volume. So it also says estimate. We're not going to estimate. We are just going to measure right now. So I'm on page 234. All right, let's look at this together. Avery has a jar and a cup. How can she use a 1-liter beaker to find how much water each object can hold? Well, first off, let's see what a beaker is. A beaker is what you use in science class in a lab. So a beaker is the one that has all these little measurements up. Kind of looks like a measuring cup you might use at home, but it holds more water. So she has that beaker. I'm just going to call it B. She has a jar, and then she has a regular coffee cup. How can she use a 1-liter beaker to find how much water each object can hold? So this one we know is going to be 1 liter, and that L stands for liter. Underneath, we see the 2 metric measures. Now, metric is used in every country except the United States. You will see it used. We use something called the standard system, where we don't measure with metric all the time, but you do see things like liters in the grocery store all the time. When you go and get soda, it comes in 2-liter bottles, or you can get liter bottles. So you will see the metric term liter used. 1 liter equals 1,000 milliliters. Milli right here, well, never mind, don't put that, sorry. Changed my mind midway. It says use liters to measure large amounts of liquids. A liter is about 4 juice glasses. So if you think about a juice glass, it's not too big, but 4 of those would be about a liter. I always think of a 2-liter soda bottle, and you can see the 1-liter ones too. They're half of that. It's really not a whole bunch. Use milliliters to measure small amounts of liquid. There are 20 drops of water in 1 milliliter. When you get into science classes higher up and you start measuring out water and you do science experiments, you'll use milliliters. Milliliters are very tiny. So 1 milliliter is 20 drops of water. Avery can fill the 1-liter beaker and pour it into the jar. It takes her 3 times to fill the jar, so the jar holds 3 liters. So if my jar right here, if we fill the beaker up and we pour it in, it's going to take her 3 times to do it. So if I use 1 liter 3 times, then that means that this holds 3 liters of water. Avery can fill the cup and pour the water into the 1-liter beaker. So think about it that way. That's the creative way to do it. She's going to fill this up. We're going to use green water here. She's going to fill it up, and then she's going to pour it into the beaker and measure how much water it holds. So to find the volume of the beaker, find the line where the water stops. The water stops at 600 milliliters. So if you look at your picture, it goes up 100, 200, 300, 400, 500, 600. So the water stops right here. So we say that's 600 milliliters. And milliliters is a little m and a big L. It's not a liter, so I can't say that the cup holds 1 liter. It holds 600 milliliters because it's smaller than a liter. So let's look at what they have next. If you look at numbers 1 through 3, it says write less than a liter, about a liter, or more than a liter. If you have a cooler is pretty big. A cooler is going to hold a whole bunch of liters, so it's going to be more. The next one is a juice glass. A juice glass is, we just learned 4 of those makes 1 liter, so that's definitely less than a liter. A water bottle, a big one like that, definitely could be a liter. Then you get to numbers 4, 5, and 6. On these, let me clear this out. They give you a beaker, and I'm just going to use a rectangle. And they would start, I have to zoom in, so give me just a second. They started at 100, 200, 300, 400, 500, and we keep going all the way up to 1,000. So I'm going to keep going. 600, 700, 800, 900. We're going to barely put it in, but 1,000 milliliters. All of those are milliliters. This whole thing is a liter. So the one they give you water that goes right through here. So we look at where the water stops on what line, and it stops at 300. So it would be 300 milliliters of water. Then it goes down to, it gives you some more pictures, and it says which would be better to measure each volume, milliliters or liters. If you have a big fruit punch bowl and you want to serve a bunch of people at a party, you're going to probably want to use liters. I don't want to think about terms of fruit punch and little drops of water, which is what milliliters are. A spoon, however, if I fill a spoon up, I could easily fill it up with 20 little drops of water, which is a milliliter. I can't fill a spoon up with a liter. It's too much. So what they want you to do is just figure out, number 1, how to measure it, just like we did here. And then number 2, what's the better thing to measure with? A rain barrel, for example, is another one they give you. Rain barrels are pretty big. They, you think of barrel and you think of a big thing. Anyway, those we would use liters. Now, if you have a bowl of cereal and you had milk in your bowl, you wouldn't want to measure that in liters. It's too big. So you would measure that in milliliters. So what you need to be able to do here is know how to measure it. And it's real simple, just wherever the line stops. And if we asked you, what would you measure a juice box in, milliliters or liters? Just pick which one would be a better fit. Okay, so let's go to the next one. And by estimate, I guess they don't really mean estimate like you think of when you think of rounding and things like that. They mean more of what would you use to measure it? Like think about your foot. This was a question we had in 5th grade last week. I would not measure my foot with a yardstick because a yardstick is 3 feet long. It's 36 inches. I don't have a 36-inch foot. I would just use inches. So the next one is page 236. And on this one, they do operations with liquid volume. It says Donovan has a fish tank that holds 15 liters of water. He uses a pitcher that holds 3 liters to fill the tank. How many times does Donovan fill the pitcher? So his tank, his fish tank, holds 15 liters. He uses a pitcher that holds 3 liters. Now, it's not a picture like a pitcher frame. Pitcher looks like that, and that's why you might put tea or lemonade or whatever in. This holds 3 liters. So he, not he, but whoever's solving the problem, it does a little chart. So this is an in-out chart we're going to do. So this is the number of pitchers he's going to need and the number of liters. So 1 pitcher has 3 liters. 2 pitchers has 6 liters. 3 pitchers has 9 liters. 4 pitchers has 12 liters. We're going up by 3. 5 pitchers has 15 liters. Another way to do that is to take the 15 liters and divide it by the 3 liters you keep pouring in to get 5 pitchers. Okay, division. When they tell you how many times does he fill it, that's a clue for division. And then if you ever see the word each, that's another clue. So let's do one more like this. These are not the actual measuring. This is using the actual measurements to solve a problem. Let's do number 2. A beaker contains 750 milliliters of water. Jonah pours out 400 milliliters. How much water is left? Left means I subtract. So I'm going to subtract it. I started with 750. We poured out 400. Let's see how much we have left. So let's subtract 4, 5, 6, 7. I get 350 milliliters left. Okay, so these are pretty simple. So I'm going to move on now to the next one. And let's go to mass. Okay, now mass is different than weight. So let's look at this one and let me figure out what page it is. We're on page 240. So it says Clark has a new phone. Does Clark's phone have a mass that is greater than 1 kilogram, about 1 kilogram, or less than 1 kilogram? Mass is the amount of matter an object contains. The 2 measures of mass are grams and kilograms. Now, mass is not weight. It's not how much something weighs. If you hear somebody say that mass is how much something weighs, they're incorrect. It's very similar, but weight has to do with gravity, which we're not into yet. So mass is the amount of matter in the object, how much matter makes up this phone that Clark has. So we can use grams or kilograms. There are 1,000 grams in 1 kilogram. So it says you can use benchmarks to estimate and compare mass. Now this is something that you learn now and you will remember forever. A paper clip is about 1 gram. So 1 gram equals 1 paper clip. And you know how light a paper clip is. So 1 kilogram would be 1,000 paper clips. 1 kilogram is about the heaviness of a baseball bat. So that's more heavy, of course, than a paper clip. I'm just put baseball clip, sorry. Baseball bat. To find if Clark's phone has a mass of more than 1 kilogram, about 1 kilogram, or less than 1 kilogram, compare its mass to the mass of the baseball bat. So if we have the phone, we need to think, what does it compare to? We need to think about a baseball bat. A phone is not going to be as heavy as a baseball bat, so it has less than a kilogram. So a phone is less than 1 kilogram. It's definitely going to be more than a gram because you know that a phone is heavier than a paperclip. So if we look further down, if you think about a bag of potatoes can be pretty heavy. So we would say that's about a kilogram. If we have a recliner, that's very heavy and it's way heavier than a baseball bat. So it would be more than 1 kilogram. A glass that they have here looks empty, but it would be less than a kilogram. Okay. So that's kind of what they want you to do here. Look at the animals. They give you a horse, looks like a seal, and a mouse. And then they give you the options of 25 grams, 25 kilograms, 400 grams, 400 kilograms. So if we look at the horse is going to be the heaviest one here. We would say it's about 400 kilograms or about 400 baseball bats. A mouse is going to be the smallest one we have, so it's going to be about 25 grams. Mice are not very heavy at all. The otter or the seal, I would say he would probably be about 25 kilograms. I don't think he would be about 400 grams. So he'd be about 25 kilograms. So the 400 grams they give us is just for nothing. All right, let's go on to the operations with that. We're moving through this pretty quick because it's pretty easy stuff. Okay, let's look at page 242. It says a restaurant has a 20 kilogram bag of rice, so 20 kilograms. After dinner, 17 kilograms of rice remains. How many kilograms of rice were used for dinner? If you see used, we're going to subtract those two. 20 minus 17 is 3 kilograms. So if we had 20 kilograms, we used up 17 of it. We need to see how much is left. Left is another keyword here that you would use for subtraction. You don't need to do the bar model. You guys can just subtract it. 20 minus 17 is 3, so 3 kilograms. We don't need to do all the extra stuff. Let's look on page 243 at number 4. I don't want to do too many of these because I don't know what you'll do in class. Miles has 6 piles of newspapers. So I'm going to write that. 6 piles of newspapers with a total mass of 48 kilograms. If each pile has an equal mass, what's the mass of each pile? Well, each is a key word for division. So we want to look at division for this one. Each tells me to divide. I always start with the bigger number when I'm dividing. So we're going to take the 48 kilograms divided by 6 piles. 6 times 8 is 48, so 48 divided by 6 is 8. So the mass of each pile is 8 kilograms. Okay? We can check that by saying 6 piles times 8 kilograms is 48 kilograms, which is how much the whole pile is. So these are pretty simple, just little problems that you're going to solve. You need to be mindful of your keywords like each, in all, things like that. All right, so that's going to be all for measurement. As always, if you have any questions, email me or come see me at school if you're not a virtual student, and I can try to help you. Let me know if you need any help.